whether or not we are alone in the universe is certainly quite a doozy. Among other things, it determines how we see ourselves, how we see the rest of the cosmos, and how we see the future. You know, until 1923, it was widely thought that there was just one galaxy in our whole universe. That thought, of course, was eventually disproven, and the universe is huge. Like, take the Hubble Deep Field image. Look at that picture. Every little speck. A galaxy massive in size. And at only 6/100ths of the sky. That is tiny. Like, take a quarter. Stretch out your hand, and the area this quarter is taking up is the area of the sky that picture is looking at. And I'd say there's probably around 100 billion stars per planet pictured there, which is, pretty impressive, but it pales in comparison to the number of stars in our universe. According to the European Space Agency, there are approximately 1 times 10 to the 24th power stars in the universe. Or, in other words, a 1 followed by 24 zeros. That is enough stars that if you turned each star into just a cubic yard of Earth, that would be enough dirt for 706 Earths. And by the way, there are only 70 Earths pictured here. As you can probably already tell, this universe can be a crazy, terrifying, spectacular, and crazy place all at the same time. I'd say the only thing it's not is boring, so as a human race, we should take an interest in it. Today, we will look at the Fermi paradox. To do this, we will first look at the Drake equation, one of the main bases of the Fermi paradox. We will then look at the paradox itself, and finally, a couple possible solutions to the Fermi paradox. So, let us begin, and I hope you like variables, because I have an equation with quite a few variables for you. The Drake equation is n equals r to the subtext of star times f to the p times n to the e times f to the l times f to the I times f to the c times l. Got it? It was originally created for SETI by Frank Drake. In its slightly more understandable form, it goes as follows. The number of civilizations in our galaxy with which communication might be possible equals the average rate of star formation times the fraction of stars that have planets times the average number of planets that can support life per star that has planets times the fraction of planets that can support life that actually go on to develop life on their planet times the fraction of planets with life that go on to develop advanced civilizations times the fraction of advanced civilizations that create a technology that releases detectable signs of their existence into space, times the length of time for which such civilizations have released detectable signs of their existence into space. Using, according to Adam Frank, professor of physics and astronomy at the University of Rochester, using this equation, we can tell exactly how low the probability of advanced life arising would have to be for us to be the sole civilization in our universe. He did the math, and we are likely to be the only civilization this universe has produced if the likelihood of advanced life arising is 1 in 10 billion trillion, or roughly equal to the chance of flipping a coin and getting heads 89 times in a row. This brings us to the paradox itself. It is, in essence, the question you're probably asking yourself. If, according to our math, there are probably billions of advanced life or civilizations out there, where are they? It was originally thought of by Enrico Fermi. He knew with just rudimentary rocket technology, it would take only 10 million years to colonize the galaxy. The universe is an estimated 13.4 billion years old. That's plenty of time for spacefaring aliens to spread. But where is the evidence they ever did? Nowhere. Over 50 solutions to the Fermi paradox have been proposed. But don't worry. Instead of regaling you with all the details from every single one and going for the record of longest speech ever made, I'll tell you about just 3. The first solution we'll look at is the Great Filters Theory. It originates from a popular 1998 article by Robin Hanson titled The Great Filter. It is the theory that there is some natural factor, something about the nature of life in the universe itself that makes advanced life extremely hard to achieve. Maybe all civilizations destroy themselves soon after they invent nuclear weapons. Or maybe there's some step on the road to becoming an advanced life form that is a lot harder to accomplish than we currently think. The difference between most possibilities do not matter. But there is one difference that does. Whether the filter lies ahead or behind us. If it lies ahead, in the future we will face most probable doom. If it lies behind, we can look to the future knowing that we were the extremely lucky species that got past the filter. And now the universe is our oyster. Now, make sure that's secure. What if we have been visited by aliens? In 2017, the United States Navy confirmed that a video that had been released of a UFO the United States Navy confirmed that a video that showed a UFO darting around the sky before moving left out of frame too fast for USN sensors to reacquire it was indeed real. I'm not saying that these are aliens. We don't know what they are, but there's no evidence to suggest that they aren't aliens. And no matter what, there has to be some explanation for it, extraterrestrial or otherwise. And additionally, since the first reports of fiery discs over Egypt in 1440 BC to today, there have been thousands of reported UFO sightings. Now, the final proposed solution I'll share with you today is a little weird. It is the theory that every civilization eventually develops VR technology so good that they can't tell the difference between reality and virtual reality. This is not out of the question to see. VR technology is advancing at breakneck speeds. You may ask what this has to do with the Fermi paradox. The answer is, what if our ancestors, who lived in the real universe, put us in one of these civilizations? What if they met real aliens and were so utterly terrified by them that they trapped us in the simulation? The scary thing about this is that we will never know if it's true or not. Like, as previously mentioned, this simulation is so good that we cannot tell the difference at all. This means that if it is the solution, we will forever look upon the empty stars, wondering why they are so empty, not knowing that we made them that way. So, we've come full circle. We have established the statistical probability of alien life and how that probability, combined with the lack of evidence, form the Fermi paradox. We have discussed a couple of possible solutions to the Fermi paradox, but we've still not answered our question. Where be them aliens? Though we may not have answered the question today, by talking about it and opening our minds, we have come one step closer.